Okay, in my previous video, I gave a full solution of the two-body problem in the case of circular orbits. But here is a thing that we can do a trick and replace this two-body problem with a one-body problem. And how is that done? That's what I'm going to tell you here. And it's done by introducing the concept of reduced mass, given by the two masses, like this. And this reduced mass is orbiting also in a circle. And it's interacting with the total mass in the center. And that is a fixed mass. It's never, ever moving. It's only this one, the reduced mass, that is moving. So this should simplify the problem then. So let's find out then if we can solve the problem. So there will be a force interacting like this. The reduced mass times the acceleration. And the acceleration, that's just a centripetal acceleration in order to do the circular orbit here. And that can be written like this. Omega squared times the radius, which is capital R. Okay, so then R equal what? F divided by omega square and 1 over me. But what is that? That is that guy here. So it's m plus m divided by mm. So, and that equals what? Let me see here, 1 over capital M plus 1 over M. And we are done. So that is exactly that result. So that's how you should solve problems. The two-body problem should always be replaced with the one-body problem and just using the reduced mass. But just to be sure, the force I'm saying that here, that the reduced mass is feeling, is it really the same force like here? Okay, let's take a look. So what is the force in a gravitational problem? Yeah, it's Gmm over R squared, right? See, this guy here, he's feeling a force. And as Gmm and the distance between them is capital R, right? And the same for this one in the other direction. So now let's go and take a look. What could that be? Yeah, Newton's law of gravitation is saying the following. G times one mass. Here is one mass. M plus M times the other mass. Me. And what is the distance between them? Capital R. And what is this equal to? Gmm over R squared. It's exactly the same. Okay. Like, subscribe if this was funny for you. Thank you.